All right, I'm pretty excited about today, and I'm glad to be back. RF Hacker Sanctuary had me come back for a presentation this year for DEF CON. I go by cemaxecuter, also Aaron. And today I'm going to be talking about what I think is a pretty unique feature of DragonOS, which I'll talk about here shortly. But RF signal propagation and visualization with DragonOS, everything kind of built into a Linux distribution and doing all this on Linux. And so we'll get into this and then we'll do some hands-on. But let's take a look here a little bit about me. I can see kind of like the icon there. Put a lot of videos on YouTube to help others with software-defined radios. And to do that, I created DragonOS primarily during, well, the height of COVID-19 during the lockdown. I thought, what better thing to do than to mess with software-defined radios because the electromagnetic spectrum is all around. So regardless if you're in the house or out, give you something to do. So that's kind of how that came about and why that came about. That's the short version of it. Uh, what do I like? Well, first, who am I? Electromagnetic spectrum enthusiast. I'll just go with that title. It sounds pretty good. And interests, spending long hours thinking about what to add to DragonOS. Yep, that's pretty true. Uploading YouTube videos about it, and then, according to other people, talking about it accessibly to others. But when you're pretty excited about something, you can't help it. All right, let's take a look at some acknowledgements here. Um, Most of these, well, all of these people I'm about to talk to, I've not actually met in person. So the images over on the right, I'm pretty certain that's who they are and what they look like, but I could be wrong. So first off, Dr. Walker, and I'll explain a little bit how I found this gentleman here. You can see his picture over on the right at the top there. Uh, he really helped out with SPLAT and then the conversion to Signal Server, which I'm going to talk about here. A lot of advice and help over the phone back and forth, and then help with code, um, both in giving some older code to get this kind of off the ground and going, and then helping with improvements to it. So big thanks to him. Next up, Corey here, which is actually part of the Hacker Sanctuary, and does quite a few applications on GitHub, one being DF-Aggregator, which caught my attention and can be used with the Kerberos SDR for direction finding. But I like the fact that it used the cesium backend for mapping, which lends itself well when you want to put RF propagation on a map. So his application with some modified code that he sent my way, and then kind of finagling that into DF-Aggregator for right now. Um, Big thanks to him as well. Next up, Wolfman, only ever spoke to via email. A lot of advice and help in, um, I guess, the techniques to assemble DragonOS, as well as some tools and software. And then so we got the unidentified person on the far right there. Looks really familiar. Helped out a lot with code. I hope to, if not during this presentation, maybe at the end, shortly after DEF CON, have a pretty exciting announcement as far as uh, new features that would be added to DragonOS to better use the RF propagation and visualization aspect of it. So basically, without ruining the whole surprise, complete code rewrites, great new interface, and some other stuff. So hopefully everything works out with that. All right, what am I going to talk about today? We'll talk just a little bit about Splat, and then Dr. Walker, I kind of already gave a little bit of it away, but we'll talk a little bit more Signal Server and the integration into DragonOS, and then already kind of touched on the Corey DF aggregator. Then we'll do, I guess you'd say, sort of a workshop with required getting required elevation data into DragonOS, generating signal server compatible antenna profiles. We'll do that RF propagation plot. We'll try and do a station to station plot, and then we will display the generated KMZ results. And I keep saying I'm going to show it, but I've just released an updated version of DragonOS, which do a quick Google search, DragonOS Focal, and I will try and get that maybe out or announced in advance. So if you want to download the ISO, right now it's just on SourceForge. You can download it. You can even spin it up in a virtual machine and kind of follow along with this talk or shortly afterwards if you don't get it downloaded in time. All right, so SPLAT. I wanted to do RF propagation analysis and visualization. I just keep calling it that because you can see what SPLAT stands for up there, the Signal Propagation Loss and Terrain Analysis Tool for the electromagnetic spectrum between 20 megahertz and 20 gigahertz. So researching kind of some open source stuff, I came across SPLAT and basically this page that you see here, and I read it all over. And so I don't claim to know everything about Longley Rice terrain and everything else that's involved in this, so I won't go too in depth. I just wanted to focus on getting an application going with a known working back end, and then kind of adding and learning as I go. So on this page, what stood out to me was what I have blown up here on the right was that gentleman, Dr. Walker, has created a SPLAT server with a web-based interface. I thought, wow, that's really interesting. Maybe this is something that I can incorporate into DragonOS. All right, and so that led me to Dr. Walker. You can see over on the right kind of what the page looked like earlier this year was just, hey, if you're looking at hosting a SPLAT installation, go ahead and contact me. I can see there it needed Linux and some other things, so perfect, right? I reached out to Dr. Walker, like it says there, made contact via email. He had explained that the site wasn't really no longer running, but became very interested when I discussed including his work into DragonOS. So at that point, it kind of collectively worked together on not only getting SPLAT incorporated into DragonOS, but also looking at upgrading a SPLAT to Signal Server, which is a multi-threaded. It's based on SPLAT, and it's got some improvements in it, and it's multi-threaded, so it was definitely a lot faster at computing the propagation plots. And then so we took that and got that changed over from SPLAT to Signal Server. Along the way, implemented new features to the older web-based interface, and then you can see there the fork of, or I'm sorry, not the fork, but where you can get Signal Server on GitHub there. And don't mind if, well, on the previous page you saw the error there of the way I'm having to present this and switch over doesn't lend itself well with spelling check, and I missed that. So all right, anyways, so Corey and DF-Aggregator. So you can see on the right what DF-Aggregator looks like from the GitHub page, and what it's designed to do is for the Kerberos SDR and for direction finding, but I could see the ellipses on the map, and I could kind of see how I could use this for Signal Server and for the web server application in order to have something to display the propagation plots on. Anyways, we discussed DragonOS. Was then given some code which I modified and got incorporated into DF-Aggregator to allow for a temporary solution to display KMZ files. And again, you can see where you can get DF-Aggregator there on GitHub. All of everything I'm showing is already incorporated. into DragonOS. So, but if you wanted to go out and check these out individually, there's the links. You can find out more about that. All right, so important thing that I have pre-installed a little bit of elevation data into DragonOS so that people can get up and running right after installation. But if you want to do anything more than the default lat and long that's included in DragonOS, you're going to need to get some SRTM data, which stands for Shuttle Radar Topography Mission. And there's several different types, but we are going to use SRTM 3 for this. You can use some higher definition map data with Signal Server and LiDAR, but it's not currently built into the web server function yet. On the right, which we'll take a look here in a little bit, was a page that I found and is linked in DragonOS that can get you to some really good elevation data in the correct format, which here it needs to be in HGT format, which is then converted to SDF by some utilities in the Signal Server installation here. I just have the directory for where map data in DragonOS needs to be, hard-coded in user source SDF. You can gzip it or bzip it, make it a little smaller. There's the link there for the viewfinder panoramas that is up on the right. There's also another site there for the SRTM 30 that required some sort of NASA account, but the viewfinder panoramas and elsewhere has access to data without accounts. It's just freely available. All right, so that is just the basics there. I put these links so you can read more and learn more about SRTM and everything else we're going to talk about. So I'm just going to get straight into, we'll bounce back and forth here between the presentation, and then I have a install of DragonOS running here. It's a fresh install and just remote desktoped into it with some notes here, and we're going to see how easy this is to kind of get up and running. So first things first, we need to start up the Apache web server on DragonOS, which in this case I have already started it. And what you're going to do is pull up, and we're going to go to localhost SPLAT. You'll get the web server up and running that looks like this. Again, this is the older code. This isn't the whole new remake that I kind of hinted at. And if we go to about the Signal Server site, you can see a lot of information that I've carried over from the discussions from Dr. Walker. And we're going to go down here to the HGT files. And so I've already downloaded these. You need, I'm going to do something later. I'm going to try and do Las Vegas where you all are at. I've got L11 and 12, K11 and 12, I11 and 12, which should kind of cover everything here in this chunk here. So we should be good there. And what we'll do is we'll first take a look at, all right, say we've downloaded that map data, which I have downloaded already. All right, so we have the map data downloaded. I went ahead and unzipped it already. So what we want to do is copy the contents out of each directory into the user source SDF. I'll do that real quick and then we'll come back and continue on. All right, we have the map data copied over, so let's go ahead and we'll look in our user source SDF directory. I just temporarily moved the data that comes with DragonOS kind of out of the way just so you could see what the HGT files look like. We'll open up another terminal and we'll change to user source signal server, and we're going to run the get tiles.sh file, which I'll come back here in a little bit and we'll take a look because it's going to start converting these files over to the SDF format, and that's going to take a little while, so I'll come right back. Alright, the files finished converting, and you can see I went ahead and I copied the data that normally comes with DragonOS back in there. It's zipped up, so now we have all that elevation data in there, and so that kind of completes that part. Let's jump back over, and so we'll take a look real quick. The other important thing is understanding how to create or how to use the different antennas that I've included in here. And so we'll jump back over here to the machine and we'll take a look in the user source ant folder, where I have already converted some files over from a .ant file, which in this case the ant file, let's see, let's go ahead and open one up here as an example. The AMP file should have roughly 720 rows. So there's 720 rows here, and each line is in gain and dB, and they're normally 0 or negative values. And so the ant v3 file is what we need to convert over to a SPLAT or signal server compatible file, which I have already done using the utilities here, the ant to AZEL for azimuth and elevation. We can see if we run this here, it's got a help file. So essentially you take the input file of the ant file and it's going to output the AZ and elevation. And so I did that for a couple different dipole, ellipse, Yagi antennas here. And then you can take a look at for example, the dipole file here. You can see how this is formatted. And one other thing that I've included here are MSI files, which you can find out there on the internet. Now, this is what I thought maybe we would do, because this one's a little more complicated. I've already did the ANT files, but if you wanted to convert from a .msi file to an ANT file to then to a signal server file, let's take a look at a couple things here. I'm going to, for one, I'm going to copy utilities onto my desktop. And let's see, we'll go ahead and just to kind of keep everything together here. Alright, so if we go into utilities, we're going to find a spreadsheet here. And so this spreadsheet can be used to convert the MSI files to ANT files. So let's take a look here. What do we need to do? We'll open the antenna pattern file. Let's see. Let's just pick one here, just any of them. So let's open with, open this with, open it with FeatherPad. Okay. And so what we need to do is we need to copy this information. We'll copy what's in FeatherPad here, and we're going to start on cell N1, and we'll paste everything down. I'll just hit forward and finish, and so that's pasted in there. And let's see, we're going to come down to horizontal. Everything, here we go. Alright, so we'll come over here, we'll paste into B1. And then we'll come over here into V3 for our AMP file. And now thinking about it, it would have been 721 because we're down here. Okay. Anyways, we got our information converted over. If we create another AF 5G 23-S45.ANT file, open it up, paste the contents in there. We'll go ahead and save the changes. We'll jump back over here. We can go ahead and change to our desktop utilities. And so if we do the ANT to AZEL, let's go ahead and we'll do -N AF-O 23 and so now we end up with our two .az and .el files for SPLAT. Alright, last but not least, we'll take a look when dealing with in the var HTML SPLAT signal server folder is where you'll find most of this older code here. And if you look at the what I've done just for now, which this will be made a little more advanced in the future. If you look here, there's a transmitter, antenna type, and azimuth, and those values are being pulled from the user source ANT directory. So if you copy those antenna files over to the right place, I'll then show how you can call upon those. So that's just a quick down and dirty on the antenna. Let's take a look at RF Propagation Demo. Here's where we're going to get a little more exciting. So we'll start simple here, and we'll go with something I've already put in here. It was just a test. I enrolled a transmitter, and we can see I added these lines here for now. There's no error checking or anything, so you better enter exactly what's over to the right here. We'll do a 90 degree on the azimuth. Leave it at 146 megahertz. Leave the ERP as is. We'll just kind of go down here and just do a Longley Rice plot. You could do a line of sight plot. You could also have multiple transmitters in the database, because this all gets saved to a database here on DragonOS, and then you can call upon those locations. So not only can you do your RF propagation splat, you can plot out the little flags where all your other transmitters or stations are at. I should also point out this was originally kind of made for ham operators, so when you're enrolling in the database, it's more about the user and a call sign. You don't have to strictly stick with a call sign, although there is some checking on the variables that are put in, so you might have to mess with that. If you put some really long or some odd name in there, it might not get into the database. So, but in the future, looking to change all that. So let's go ahead and create a plot that's going to run the signal server in the background. with the variables that we've passed to it, which right now I have it displaying the output. That will probably be turned off just to have this page cleaner. But now we can see we've got this plot here with the antenna pointing off like how we kind of set it up to be. And so let's go ahead and let's try one more here. Let's enroll. Okay, there we go. We'll go ahead and we'll put this KHSV in here. I looked it up in Las Vegas there. Antenna height in feet above ground. We'll go with 1266. And the location. All right. We'll just stick with the kind of everything else the same is fine. We'll submit registration. That gets put into the database. Let's go ahead and search the database. We got KHSV. Let's go with, we'll leave it at default here. We'll leave the azimuth at default. Channel 2 digital. We'll just go with 60 megahertz. The ERP in watts was 27,700. And we'll go, so that's the target's antenna height, like somebody's house or something, their antenna. And let's try 60 miles here. We'll do a plot on this, and hopefully we have all the elevation data to cover the calculations, which we should. Alright, so we got a pretty good plot there, and let's take a look. So we're going to look at displaying the KMZ demo, and that will tie into what I'm about to do here. So we'll download this KMZ file, and before we display this in DF-Aggregator, let's go ahead and put one more in the database here, and we'll see if this fits in there. DEFCON, and let's see, 36. And we'll just leave everything else default. And so what we want to do is we'll do another some propagation analysis between the two locations. Okay. Go ahead and change that back to 60. And we'll create a plot between the two locations here, and we'll see what we get. Alright, so now we have a plot between the two that's going to show the line of sight, curvature, terrain, Fresnel zone. And we can see how far apart is this elevation. So obviously not maybe the best thing here. Distance 591 miles. So we can see our free space path loss, attenuation, and then of course there were a lot of obstructions, and then where they were detected at, because I probably either put a number in wrong or really didn't check how far away the antenna was. But anyways, you get the idea here. Yeah, I must have fat fingered something, and but that will get you the distance between the uh, two locations and some information, as well as a KML file here that we'll download. But just because it's not going to work out so good, we'll just do a test 2, and we'll change, let's see, change a little bit of the information here. Let's go between test 1 and test 2. Create a plot between the two. In this case, we're under a mile here, and we can see we'll use this one um, to show the station to station. All right, so now we've got our plots done, and we want to take a look at what this looks like visually. So we'll change our user source DF-Aggregator, and we'll do a DF-Aggregator DF-Aggregator, and because I did some modifications to this, it still needs a database set up here. So we'll just go home Dragon DEFCON, and we'll do O. That'll start up web server on 8080. So let's take a look at localhost 8080. All right, so this is DF-Aggregator, and we're using cesium, and of course we've got internet to get some map data here. I'll change it to world imagery. If you put a cesium key in, you can get some better data there. And so up under here, we've got file upload option. We'll look in our downloads, and we'll start with the KHSV, and let's see, hopefully we got that right. We'll let it load up here. Let the map load. And we can change opacity here. It looks about right. And we can see what that looks like over the area there. The color scheme, which might not have been so obvious, was actually back on the plot page. I'll let that run in the background. We'll take a look at that here just to make that a little more understandable here as far as what these colors are. So that's the important of it, the elevation data, because that's what you're doing the calculations against to get this propagation display here. And let's go ahead and we'll take a look at the, actually this just finished. So if we look here, all right, we'll let that, should be almost finished. We'll take a look, we'll open up our test 1 to test 2 location. We'll go check that out here in a second, but I just wanted to point out the color scale here shows the dB, for the power level here, and so that's where you get that at. You can download that and have that as a reference. Now this is the station to station that we just quickly made up here, and so if this was over a greater distance and there was an obstacle there, you'd see another kind of yellow line following along with the white line. Where the yellow line stops on each end is where the obstructions are for line of sight. All right, so we kind of covered quite a bit there, and I wanted to make it hands or interactive so that if if you got this and wanted to do it on your own, at least you could get started in the right direction and get it up and running. So that kind of completes the demonstration part. I'll just close it out with um, on SourceForge, you can grab DragonOS. The latest DragonOS is there. Kind of the future I hinted at is having a completely revamped GUI to do all that, as well as maybe take advantage of all the features that Signal Server allows, or maybe even I've kind of just noticed here recently a new version or newer version of SPLAT in the works, which is kind of interesting. I have to take a look at that. And then if there's any questions, just drop it in the comments and I'll try and answer it the best I can. So if I didn't say thanks to really the entire open source community has really helped make DragonOS. I could go on forever. The developer of SigDigger, SDR for space. I mean, just a plethora of great applications out there and people that have helped along the way that I would have had to fill this whole slide up with names. So really, thank you to everyone. Thanks to RF Hacker Sanctuary, the people at DEF CON. I hope that this helps out in some way with, wireless, at least understanding what the wireless and the spectrum looks like around you, or if you had some need to model out a transmitter, hopefully this helps. All right, and thank you. Be safe. Have a great rest of your time at DEF CON.